Good day all, and welcome once again to my channel. This time we are going to be looking at chemistry, and we are going to be focusing on an aspect of chemistry that is on calculations. And many students, they often find calculations very difficult for them to comprehend, and this one happens to be one of them. So it's with my hope that after this video lesson you'll be able to understand everything about empirical formula and molecular formula determination. Alright, so let's just get right into it. Now I want you to pay attention, be very focused and be very attentive as we run through the series of empirical formula and molecular formula. Now when we start by looking at empirical formula, the question is, what is empirical formula? You can simply put it this way, that empirical formula is a formula that shows the simplest whole number ratios of atoms present in a compound. The simplest whole number ratios of atoms present in a compound. Simplest whole number ratios. Alright? Number ratios of atoms present in a compound. Alright? So while molecular formula, this one, it tends to show the actual number of atoms present in a compound. The actual number of atoms present in a compound. The actual number of atoms present in a compound. Alright? So, it's just like you saying that, you know, there is actually a formula which is known as the formula of glucose from your photosynthesis lesson in biology. It's given as C6H12O6. So you can call this the molecular formula of glucose. But if I should tell you to represent the atoms in their simplest ratio present in this compound, it will be entirely different representation there. So in that case, we now call it the empirical formula of glucose. Because looking at this, we have 6 atoms of carbon, 12 atoms of hydrogen, and 6 atoms of oxygen. So if you want to represent in the simplest whole number ratios, it simply means that C6H12O6, we are to divide all through by 6. If we should do that, that becomes by 6 by 6, because it's only 6 if you check as a factor that can actually reduce this to the simplest form. So 6 into itself is 1, 6 into 12 is 2, and 6 into itself is still 1. So at the end, we are going to have just a carbon, 1 atom of carbon, and then hydrogen will now become 2, then while oxygen will now be 1. So this is the empirical formula of glucose, while this one is the molecular formula. You see that what I said? The molecular formula shows the actual number of atoms present in a given compound, then while this one only shows the simplest whole number ratios of the atoms that are present in a compound. I hope that is clear. Then let's look at how we can actually calculate for empirical formula and molecular formula. Now we have 2 questions on the board. Maybe in the course of going through the questions, I'll be revisiting or maybe revealing those laws that we need to obey. Or let me just give you. Now looking at it, any question you are given in empirical formula, just know that most of them, they come in the form of their percentages, meaning you are given a particular compound in the empirical formula question, and then you are actually given the percentage compositions of the elements of the compound. So what are you supposed to do? In order for you to get the empirical formula, you simply divide the percentages that we were given in the question of the elements present in the compound by their relative atomic masses. You understand? That's the first thing you should do. Now, there are percentages that are given in the question. You divide all through by their relative atomic masses. Then the next thing you should do is this. After you've gotten values by division of that, the percentages by their relative atomic masses, the values that you now arrive at, the next step to take is to divide all through by the smallest value. Let's say you're having 3 elements, A, B, C, and then you have the percentage composition of A, B, and C, respectively. And then you divide all through by their relative atomic masses, that's relative atomic mass of A, B, and C. Then the values you have arrived at, then you now check the one among the A, B, and C, the one that gave the smallest value. So the one that gave the smallest value, you should work with that smallest value, and you now divide all through by the smallest value. So anything you now get will now become the ratios, that's the empirical formula ratios, the simplest whole number ratios. Then you can now extrapolate these ratios and then get a standard compound, which is known to be the empirical formula. I know this might not be that very clear to you, but when we start looking at questions, then it will be very, very clear. Let's dive into looking at questions now. Looking at that question 1, considering question 1, we were told that what is the molecular formula of a hydrocarbon with molecular weight of 30 grams per mole, which consists of 80% carbon, and then we are given the relative atomic masses of carbon and that of hydrogen. Alright, now let's dive into looking at the question. First and foremost, the formula mentioned, the compound was actually hydrocarbon. And you are aware that from my previous video lesson, if you can see, check, I did a video lesson on hydrocarbons where I said that hydrocarbons are compounds that are made up of hydrogen and carbon only. Hydrogen and carbon only. So it means that in this compound we are going to be having just 2 elements, hydrogen and what? And carbon. So you can just make a tabular representation, hydrogen and carbon. Now the next. Now we are giving 80% of what? Of carbon. Now we are not giving a percentage of hydrogen, but we are only told 80% of carbon. So it's obvious that what makes a percentage is 100. And then we are giving 80% of carbon. So the leftover percentage should go to hydrogen. You understand the point? So here is 80, and over here it's obvious it should be 100 minus 80. That becomes what? 20%. So we are working with 20% here and 80% there. Then what did I tell you you must do? You divide this by its relative atomic mass, which is 1. This one. And then you divide this by its relative atomic mass, which is 12. Alright? So what we do that, this gives us 20, because 20 by 1 is 20, and 80 by 12 with the help of our calculator. Let's just quickly look at that now. 80 divided by 12, of course that gives us 6.67. 6.67. Then now the next thing I said, if you paid attention, was we will now divide all through by the smallest value. Now 20 and 6.67 is obvious that 6.67 is smaller than 20. So we have to divide by this value, 6.67 and 6.67. That's just how it works. Alright? So 6.67 by itself, that becomes 1. And 20 divided by 6.67, 20 divided by 6.67, that gives us 2.99. 2.99. Now coming to this, when you have, pay attention, this is a very, very important thing that you need to take note of in empirical formula. Whenever you are determining the empirical formula, please, when you have 0.3 or through to 0.7, you cannot approximate. Normally, you know in mathematics, you'll be told, or you've been told before, that from 0.5 and above to 0.9, you can actually approximate, or you can round off. Then from 0.0 or 0.1 to 0.4, these are numbers that cannot round off. Now, when you have a range of 0.3 to 0.7, please don't approximate. Don't approximate. Just look for a way of maybe multiplying all three by maybe a common factor of 2 or 3 or 4 or 5, in order for you not to be having this range. You get the point? So the only values that you can approximate in empirical formula are 0.1, 0.2, then 0.8, 0.9. You get the point? You know these ones cannot round off now, so you just assume it that they are actually 0. That's what I meant. Then why 0.8, 0.9 can round off, so you give 1 to the next. That's the one that comes before the number. So looking at this, in this case is 0.9. So I can as well just round off and then just give 1 to that. That becomes 3 as a whole value. You get the point now? So it's now 3 and 1. So if I'm bringing the empirical formula out, it becomes our H is 3 in terms of extrapolating it. Then our carbon is 1. So that becomes CH3 as empirical formula. But now they said in the question, what is the molecular formula? We are not told to calculate empirical formula, we are told to calculate molecular formula. But the thing is this, you can't get molecular formula without calculating empirical formula. So now that we've arrived at empirical formula, then there's actually a formula for calculating molecular formula. And that formula is given by molecular formula is equal to empirical formula multiplied by n. Alright, don't worry, I'm going to explain this better. So it's just for you to take note of this, that for you to obtain molecular formula, you have to get your empirical formula and then you multiply it by n. But looking at this, were we giving the molecular weight? Yes, of course, we are giving the molecular weight to be 30 gram per mole. So we can actually use, with the help of this stuff now, we can actually just use it and then we'll get our answer correctly. But mind you, I can replace this molecular formula with molecular weight. Please follow. Now, if I replace it with molecular weight, certainly our molecular weight that was given there now happens to be what? To be 30. So we just put our 30, which is equal to, then for empirical formula, we want to determine the molecular formula. So for empirical formula that was given, we add it to be CH3, then N. We can just put the N outside, whichever way. Then this becomes 30 equal to, now what's the relative atomic mass of carbon? It is 12. So that becomes 12, then plus, you sum up. Then the relative atomic mass of hydrogen is 1, then times 3, there is 3, then N. So of course this becomes 30 equal to, this will be 15N. You get the point now? So that becomes what now? For we to add our N value, then it becomes 30 over 15. Because we have to divide both sides by 15 to get the N. And that ultimately gives us what? 2. So our N value is 2. And don't forget that from this formula, for you to obtain molecular formula, empirical formula times N. You get the point now? So now we know our N value. So we can just bring it out and say that, okay, molecular formula is equal to empirical formula, which happens to be CH3, then what's our N? Instead of putting N here, we now know the N to be what? 2. So when we do that, that becomes, this 2 is going to affect everything there. So it becomes what? C2H, then 3 times 2 is what? 6. So this is known to be our molecular what? Formula. Alright? So that is our molecular formula. So it's that easy. All you just simply do is just to understand this very, very well. Understand this. Alright? So that's that about that. That's for question 1. Then for question 2, you can as well just pause the video and then take down everything. Then let's move on to looking at question 2. So looking at question 2 there, we are given what is the molecular formula of an organic compound with molecular weight of 180 gram per mole, which consists of 40% carbon, 6.67% hydrogen, and the rest oxygen. They didn't give us oxygen, but we are expected to get it ourselves. Alright? Now looking at this, it will be very, very easy. All you simply just do is you just bring out the elements in question. The elements, we have carbon, that's 1, then we have hydrogen, that's 2, H, and then we have oxygen, that's 3. So now looking at it, our carbon, the percentage was given to be 40, then our hydrogen percentage I was given was 6.67, that's the percentage. Then for oxygen, what are we supposed to do? It simply means we have to sum up these two and then subtract from 100 in order to know the one that is left. So 40 plus 6.67, that should be 46.67. So 46.67, then we have to subtract from 100. We have to subtract that from 100, and this gives us 53.33. 53.33%. Alright, so that should be for our oxygen. Now, what is the first step to do? You divide all through by what? Their relative atomic masses. For carbon is 12, given there. Hydrogen is 1, oxygen is 16. Let's do that. 40 divided by 12. 40 divided by 12, that is 3.33. So 3.33. Then this will be 6.67. So just Then y 53.33 divided by 16, that is also 3.33. So it's obvious we have to divide all through by the smallest value. Don't forget, obviously remember that we have to divide all through by what? The smallest value. 3.33, 3.33, 6.67. So obvious the smallest value is 3.33. So when we divide by 3.33, that gives us something like this. 3.33. This will be 1, and this will be 1. Then for 6.67 by 3.33, 6.67 by 3.33, that should be 2. Yeah, 2.0. So it's approximately 2. So bringing the value, the formula out, the empirical formula out, that becomes what? CH2O, because we have 1 carbon, 2 hydrogens, and 1 oxygen. So this is the empirical formula. But were we told to get the empirical formula? No. What were we told to get? We were told to get the molecular formula. And for we to arrive at the molecular formula, remember that we have to work with, remember the formula, molecular weight or molecular mass is given by empirical formula, all in N, or multiplied by N, it's the same stuff. Alright, so what's the molecular weight now of that compound? It's given as 180 equal to what's our empirical formula? CH2ON. And then of course that gives us 180 equal to what's our carbon? 12 plus, then hydrogen is 1 times 2 is 2 plus 16, all in N. And that becomes 180 equal to 12 plus 2 is 14. Then 14 plus 16, that should be 30 N. Alright, so when we divide both sides by 30, we'll do that, I think we are going to arrive at, now 3 into 18 is 6. So our N is 6, alright? So if our N is 6, then our molecular formula will be given by our empirical formula, which is CH2O, then N, right? So our N value is given to be 6 already. So molecular formula, therefore, will be, since here is 6, that becomes, in place of N, we just put 6 there. So that becomes C6, because 6 is affecting everything. Then H, 2 times 6 is what? 12. Then 1 times 6 is also what? 6. And don't forget, if you remember this formula is called formula for glucose. Alright? So the empirical formula is that, while the molecular formula is that. So it's that easy. So what I just want you to do is, you can check for multiple questions on this, and then you try your hands on them. And I pray that it's with my hope that everything that I've just explained with regards to the empirical formula and molecular formula will stick to your memory. So don't forget to stay tuned to this channel, especially those of you writing WAEC and JAM. Make sure you always stay glued to this channel. You can subscribe to this channel, turn on that notification bell, so that as soon as I update any video or I upload any video, you'll be the first to see it. Thanks for watching and stay tuned.